Hello, it's Michael Little Crow, Math 170. Again, I had another question on section 1.3 about piecewise functions, if I could explain them in a little bit more detail. Yes is the answer. So let me do this sort of backwards. Let me give you a setting, and from that setting, we'll set up the function. We'll draw a graph about that function, and we'll solve various values using the piecewise function. Piecewise function is exactly that. There's at least two pieces, if not more. So the example I'm going to use is, let's say we're at a grocery store and we're going to buy some things in bulk. And we're told that if we buy up to 10 pounds, if we up to 10 pounds, the cost is, cost is going to be $3 a pound. For anything up to and including 10 pounds. But then we get this volume discount. So the cost is now going to be $2 per pound. If we go over 10 pounds. Now the cool part about this grocery store we're working at is everything costs is $2 per pound as long as we go over 10. So you're going to see if you're going to get close to 10 pounds, you're probably going to want to go to 11 or so. So how do we set this up as a function? Well, what we do is we let x be equal to the number of pounds. I don't know, in my generation, this little pound sign, that was what we'd use for number. I know now it's used for, they call it the hashtag, I guess, and use it in social media stuff. So it's the number of pounds. So let's set this up. So if we go up to 10 pounds, we're going to pay $3 per pound. So the way this function will look is f of x is a function, but there's two pieces to it, so that's why we use this little thing here. And the pieces, we define two things. We define how we arrive at the output, the y value, and we define the domain, what x values that particular part of the function applies to. So if it's $3 per pound, that's 3x, right? Because number of pounds, if it was 2 pounds, 3 times 2 is 6, it would be $6 for that. So it's going to be 3x, so that is how we would get the output. But we have to go next to here, we have to specify what the domain is. Well, that's going to be for anything from 0 pounds. And again, if you buy 0 pounds, I guess we don't have to include the 0 because you didn't buy anything. Anything bigger than 0, but less than or equal to 10, that's going to be the rule, that's going to be the function for calculating the output. Now the second part, if we get over those 10 pounds, so the domain, what does that look like? Well, that's whenever x is, actually, I got that backwards, don't I? Sorry. I'm also dyslexic, I probably didn't mention that yet, but so I tend to do things backwards oftentimes. And inequalities are one of my challenges. If you have that same challenge, then we understand each other well. So 10 is going, or x is going to be actually greater than 10, not equal to 10. If it's equal to 10, we use this first one. But as soon as x is bigger than 10, we will use the second function. And if you, I sometimes mix my words, so I don't take offense if you tell me. I only take offense if you talk behind my back and laugh at me for something that I could correct. So just joking a little bit. Anyway, please let me know when I make mistakes because I do this live, I post them, and I'm happy to answer questions this way. Okay, so there's two functions. So what we've got to do here is whenever, so let's put in a few things. So what if I buy 5 pounds? So f of 5. What am I going to do? Well, first I'm going to look at the x value I have. I have x equals 5, and I look for which domain is that. Is 5 between 0 and 10, or is 5 bigger than 10? Well, clearly, hopefully, the 5 is a value that is between 0 and 10, so I use this first part of this first piece, this first function piece. It's also easy to think as two separate functions, but they're somehow related, so it's the first piece of the function. So to calculate, I'm going to take 3, plugging in 5 for x. So 5 pounds is going to cost us $15. Okay, good enough. I could plug in 0 here, but it's not really in the domain, but that would give me a 0 value. We'll do that when we graph. We'll see that we can use the boundary points to kind of get those parts of the graph. So now let's also see what happens at this turning point here, this 10, when x is 10, so f of 10. We also need to use this first piece because 10 is less than or equal to 10, but 10 is not greater than 10, right? So it satisfies this first domain, so we use the first part, the first piece. 3 times 10 equals 30. Now, what if we wanted to buy, say, 11? And we could buy, partial pounds, 10.5 if we wanted to, but I like to keep the math so we could do it mentally and understand this concept. So now with 11 pounds, we look over here for our domain. Clearly 11 is not between 0 and 10, so we can't use this first function. That's the first piece. 11 is clearly larger than 10, so we use this piece. So to calculate our expenses, what it's going to cost us, we take 2 times 11. Wow, this is cool. You buy 10, you got to pay 30 bucks. You buy 11, you only have to pay 22. You better buy in bulk. And don't tell the store manager that he's got this, because it's probably losing money at this case. Okay, so that's piecewise functions. You figure out which part of which domain that the x is in, then that tells you which function to use, which part of the function. It's really one function with pieces, but I still think of it kind of as separate functions. Now, if you're asked to graph these things, let's do just a real rough graph. And what we know is that this graph is going to look different. So basically from 0 to 10, there's one domain, right? Here's 0. We're going to have one rule to determine the graph from this area. If you wanted, we could put kind of like a dotted line to define. In this piece, there's going to be one graph, and everything bigger than 10, a different rule will be used, so the graph may look very different. Let's go with red. Okay, so let's do this. So let's find the endpoints. So when x is 0, even though it's not included in here, we'll plug it in to kind of get our domain. So plug in 0 for x, 3 times 0 is 0. So at 0, and I'm going to put this as an open circle, that's sort of the starting value, but 0 is not really included in this domain. 10 is included in the top piece. We already did that. We plugged in 10 for x and we got 30. So let's go 10, 20, 30. So we're going to get a point here at 10. X is 10, y is 30. And it's going to be a solid dot because it's included. And since this is a linear function, now if it was an x squared or something, we'd have a curve. But since it's not, we'll get a straight line. And if I remember correctly, I've got straight lines in here somewhere. There we go. Close enough. Okay, so let's go back to drawing the second part, and I'll switch colors even though it's the same graph. What I'm going to do here for the second piece, I'm going to see what would happen if I use 10. If I plug in 10 for x, I would get 20. So this was 10, 20. So what I'm going to do is at 10, I'm going to put an open circle here at y equals 20. Let me come back out here and let's go to when x is 20. 20 times 2 is 40. Oh, that wasn't too smart. I'm going to be off my graph here. So 30, there's 40. So at 20, we're going to be up here. And again, this is going to continue on forever because there is no endpoint to the second piece. But let's stick with red just to show that it really is the same function. It's the same, but there's two pieces to this function. Oops, I want to go to my I want to go to line. Let's see. So I need to practice this a little bit more, but so we get a line from here going through there and kind of continuing on forever, but not there. So it should go through the point. You get the point. But that's how we do it. There's two separate pieces, almost like there's two separate graphs, but it's related somehow because the story is the same. We're still buying the same cereal in bulk. It's just if we buy enough, we get a lower price. And so there's this region like here where, you know, and we could figure that out where it sort of breaks even as long as you got into this route. So it looks like maybe $7 or $8. You're going to be just as well to buy more, you know, buy 10.5 instead, and you're going to save some money, or 10.01, get a little bit over that 10. That's piecewise functions. So piecewise functions have multiple pieces, but they also, every piece has a domain part. And that's what you really have to check first is which domain is the input in. And then that tells you which piece you use. You only use one piece at a time. The exception to that is when we're sort of graphing and wanting to find the boundary points. I did use 10 in here, but notice I put an open circle saying that particular point of x equals 10 is not included, right? So I sort of did that, but whenever I use 10, it's got to be only, it technically is in the domain, not even technically, it is in the domain of just the first part. Okay, so hopefully this is helpful. Let me know if this has raised more questions or anything else, and I can maybe make a new video or add to it if you want to see something in particular. But give me some feedback. Let me know if this is helpful, and we'll see if we can't develop this relationship throughout the semester where I can answer questions through video in maybe more detail than I could through an email. If I can do it in an email, I'm happy to do that too. So anyway, keep up the good progress. It's great. This is just second day of class, and people are already in a 1.3. This is awesome. And that's what I encourage you to do. I've got due dates that are weekly, so you don't have to get it done. You could wait till the weekend, but if you get it done early, that's great. And the faster you work through this course, the more time it's going to give you to review the practice tests. And it'll allow you to earn more of those those points, the earning points. So you have mastery points. So once you have enough mastery points, you'll be able to open up that practice quiz, practice test for the midterm. You'll be able to practice it as many times as you want. It has a lot more problems than the test itself, but that's good. It gives you lots of practice. Go over, do it multiple times, and it'll make doing the midterm hopefully a breeze. That's the goal. Anyway, have a good evening. We'll be in touch.